This meeting is being recorded.
In this video, we're going to take a look at Chapter 12, which includes a discussion on both alcohols and phenols. So let's look at some of the topics we'll review. So all of these sections, it seems like a lot, but they're fairly short because they are focused on one specific type of reaction mechanism. And specifically this section here, 12.11, biological redox reactions. I note over here that this you will not see on your exam, anything specifically from this section, but we will review each of these other sections in different videos. So let's take a look at our first section here. So we're given some structures and we want to review what an alcohol is, what a phenol is, etc. So these are both alcohols. And if you recall, alcohols possess this hydroxyl group, this OH group. That's what defines our parent compound as an alcohol, right? If it only has this functional group, we call it an alcohol. So ethanol here is a two-carbon chain. So remember our prefix for ethane, eth. We use ethane, we take off the E, and we replace that with an OL. So this is how we would name our alcohols. Similarly, we would name our cycloalkanes using the parent cyclopentane, removing the ending and replacing the ending as OL. So we have cyclopentanol. We're told in the textbook and here both that hydroxyl groups are extremely common in natural compounds. If you know the structures of sugars, glucose, fructose, there's hydroxyl groups in those as well. Compounds are, fairly water soluble. So that's why we probably see them a lot in these natural compounds because we see water quite often as a solvent in biological processes. So we have some natural compounds given down here. We have this sex pheromone from a male boll weevil with a hydroxyl group. So it has that shown over here. So we have some isolated compounds from bacterium as well. So a variety of alcohol compounds are in our own bodies as well. So cholesterol has the alcohol functional group. And not much else, right? It has an alkene, a pi bond here or so. Then we have vitamin D, another alcohol functional group. And this compound here is fairly fragrant, used in perfumes and things. So we have many different structural types that can be qualified as alcohols. But when we say specifically a phenol, not only does it have that hydroxyl functional group, that group must be directly attached to a benzene ring. So if you see a benzene ring and an OH functional group in different locations, not connected in your compound, then it just has an aromatic and alcohol functional group. But together, they become a phenol functional group. So you may have heard of the neurotransmitter dopamine. This is what is deficient when someone develops Parkinson's. Then we have some other compounds. This is found in poison ivies and poison oaks. This causes that inflammation and irritation in skin. Spicy sensation is from this capsaicin. Things like chili peppers, and even structures like THC, tetrahydrocannabinol, right? This also has that phenol functional group. So we're going to look at nomenclature, how to name both alcohols and phenols alike. So these minor modifications, such as taking a parent, removing the ending, adding OL endings, things of that nature. So we will follow this step 1 through 5 here. So we'll look at our carbon, find the longest chain, identify the parent. This will include the carbon with the OH group attached to it. They say should, but to correctly identify your parent as an alcohol, it will have to have the OH group attached versus a substituent or side chain. Let's see here. So we want the locant to be assigned, just like substituents, right? Oh, I'm sorry, I skipped over step 2. I was getting excited to name our hydroxyl group, but of course you should identify and name all substituents first, and then we will assign the locant with, if there's a prefix, if there's diols, if there's more than one, to each substituent, and then the hydroxyl group, we want that overall to have the lowest number possible because we're identifying our parent as an alcohol, so the hydroxyl group is our priority to get that the lowest number possible. And then we'll list our substituents, numbered substituents with their locant, alphabetically in front of our parent. We will remember to ignore prefixes like di and tri, and then iso, that will be included if we have an iso form of our alcohol. So let's see our last step here. Then when we name the alcohol itself, we also have to include a locant within the name. So either the ending, or we can also embed that OL in the middle of our name. So we'll see examples of that with our practice problems from this chapter. Let's take a look here at some simple nomenclature rules that we can review. So step 1, ID your parent. So this is just an alkane over here. We have pentane, and then we see we have still 1, 2, 3, 4, 5 carbons, and then we have this bond to a hydroxyl group. So this would mean that we have a 5-carbon parent. With the alcohol functional group, we remove that E, replace with OL. So what we see down here is if this was just an alkane, this would be a methyl substituent, and our longest carbon chain has 8 carbons, so we call this an octane. If we added the OH functional group onto that side chain there, as we see over here, our parent would change its name. It will not be an 8-carbon chain as our parent. Now we would include our numbering in this direction. So we get to 5, 6 carbons because our parent, if it's named as an alcohol, will need to include that hydroxyl side, as that seems to be part of the side chain, right? This portion here would now be considered a substituent. So we have a parent hexanol, a 6-carbon chain with an OL. So step 3, so say we have a locant to assign and any prefixes to our substituents. We would give the carbon that has the OH the lowest number. So we see 2 examples down here. If we start numbering from this end, our OH group has that lowest numbering possible. So this is the correct structure where it has a 2. Our other functional group, right, our alkene functional group, if we started numbering down there at the other end where the alkene is, we would see that our hydroxyl group would not have the lowest carbon possible. And even though our total amount of substituents, we would have a 3,3-dimethyl, so that would have lower numbering overall. Our parent would not. So again, this is the correct structure over here on the left because the alcohol functional group has the lowest locant, the lowest numbering. And then, of course, we name our substituents accordingly. So these would be then 5,5-dimethyl. So now we get to our step 5. So we have this 5 carbon chain down here. So we know we have pentane. If we named the alkane parent, we have on our carbon 3 here, that hydroxide, or our hydroxyl rather, functional group. So that would give us a 3-pentanol if we placed our prefix in front. Or we could break up our parent and call this a pentan, 3-ol, and place that locant right before that ending, that OL ending that tells us that we have an alcohol. So either one of these forms is completely acceptable, follows IUPAC rules, and is commonly used. interchangeably. So you might see either of these notations with the locant for the alcohol functional group before the parent or before the OL suffix. So if we have substituents in front of the parent, then this usage down here is more commonly used. So now let's look at cyclic structures. We're going to follow the same rule. So 5 carbons in a cyclic structure is a cyclopentane. We add that OL ending. We also may see some stereochemistry come into play. So we would have to identify our sites of stereochemistry as either R or S. So if you recall, this would be a R. Our OH is our highest priority functional group, that oxygen there. So if we did our prioritization, it would look like we're S, but we know that this has to be on a wedge because our lowest priority functional group, our hydrogen, would be on a dash. So that's how we can determine, again, our chiral centers and determine our stereochemistry of those sites. And then we always have to remember to name any substituents and give locants for those. So this specific compound, the name's given down here as R,3,3-dimethylcyclopentanone. Again, some common names you may see on exams and other assignments, interchangeably with some IUPAC nomenclature given below. So we see 2-propanol is commonly called isopropyl alcohol.